Okay, let us start. This is the question from Knuckle Joint. We have to solve this question. If you see here, the question is that design a knuckle joint to transmit 100 kilonewtons. The design stresses may be taken as 65 megapascal in tension, 50 megapascal in shear, and 120 megapascal in compression. Okay, first let us write the data that was given. Okay, let us write the data that was given. First, what is given in the question? It is given data is first transmitting power, that is nothing but power is equal to 100 kilonewtons. We will just represent it as 100 into 10 to the power of 3 newtons. Design stresses may be taken as 65 megapascal. That means this is stress in tension. Tension is represented as sigma. Sigma is equal to 65 megapascal. But we have to write everything in a similar unit so that it will be 65 Newton per millimeter square. And 50 megapascal in shear. Shear will be represented as tau. Tau is equal to 50 megapascal, which is equal to 50 Newton per millimeter square. And compression, that is sigma c. Crushing, compression or crushing, both we will present it as sigma c. Sigma c is equal to 120 megapascal, which is equal to 120 Newton per millimeter square. This is the data that was given. Okay, here in knuckle joint, first we will find out what is the diameter of the shaft. After finding the diameter of the shaft, we will find out all other parameters by using the variables from design data book. Okay, actually here design data book will not be provided to us, so that we have to remember all these values. Okay, anyway, the first step is we have to determine the diameter of the shaft. We have to determine diameter of the shaft, that is diameter of shaft or rod, both you can call it as. Okay, for this we have a formula, that is P is equal to pi by 4 d square into sigma. Pi by 4 d square into sigma, where d is equal to diameter. I think everyone can see what is d in the figure. Okay, what is d in the figure? Everyone can see. Here it is d, diameter of the shaft. This is the diameter of the shaft. Here this is the diameter of the shaft. Okay, that is what we have to find out. And here the parameters I know. Over here it is, I know p value, that is given in the question. I don't know d value. I know sigma value, that is also being given in the question. Just find out d value. Okay, that is 100 into 10 to the power of 3 is equal to pi by 4 d square into sigma. Sigma is equal to 65 kilonewton. Thereby it is 65 into just d square is equal to 100 into 10 to the power of 3 into 4 by pi into 65. Can anybody tell me what is d value now?
44.
D value is equal to 44 millimeters. I think let us check one more time. I think it will not be 44. Any more answers? Any more answers? Any more answers? Is that 44 correct or wrong? Is that 44? Is my voice audible to everyone?
So
Yes, sir.
Just give me the answer then. I cannot see if you message. Okay, so one more answer I got as 44. Okay. Now I have found out d value. Then as per design data book, I have to determine other values also. As per design data book, I have to determine other values also. That is, as per design data book, D1 is equal to D. D1 is nothing but diameter of the knuckle. Here it is. D1 is equal to diameter of the knuckle, which is equal to 44. And D2, D2, D2 is equal to 2D. Here it will be D2. Here, here d2 diameter of this eye, diameter of the eye, or if not internal diameter of the uh, fork, diameter, external diameter of the fork or external diameter of the eye, that is equal to 2d, which is 2 into 44, we will be getting 88. We will be getting 88. Here d1 is equal to 44, d2 is equal to 88, and also we have to find t value and t1 value. That is, t is equal to, let us go for t value initially. T is over here, t is over here, thickness of the eye, that is t is equal to 1.25 into d, 1.25 into d, that is 1.25 into 44. Can anybody give me this answer? 44, I think 55.
55.
Yes. T3 is equal to 55. Similarly, T1. Similarly, T1. This is T1. Thickness of the fork on either sides. Thickness of the fork on either sides. That is 0.75 into D. 0.75 into D. That is 0.75 into 44. Okay. Thereby, T is equal to T1 is equal to 33. These four are important variables. D1, D2, T, T1. Four are important variables. There are some other variables also, that is D3 and also T values. You can find out, but here in derivation, I don't require these values. So I am not going to find out these values. Okay, D1, D2, T, T1 are very, very important variables, so that I have found out those values. Now, see, here I have found out all the values that are useful or required for designing a knuckle joint. Now, my aim is to verify whether this data is satisfying given conditions or not. Either my the data is satisfying given conditions or not, that I have to verify. Okay, that I will be doing from step number 2. Okay, this is all comes under step number 1. Now let us go for step number 2. Let us go for step number 2, that is design of design of if not diameter of design if not diameter of knuckle, diameter of knuckle. Okay, for that we have a formula, that is P is equal to pi by 4 d1 square into shear stress. Pi by 4 d1 square into shear stress. Here I know P value, I know stress value, even I know d1 value, and even I know stress value. But here I am going to verify my answer, so that I have to find out what is shear stress. I have to find out what is shear stress. Thereby P is equal to, already we know the value, that is 100 into 10 to the power of 3, and pi by 4 d1 is nothing but 44. D is equal to d1 is equal to 44 into d1 square, it is 44 square, into tau value. Tau value is that I have to find out. Thereby tau is equal to 100 into 10 to the power of 3 into 4 by pi by 44 square. Can anybody give me what is this answer?
65.
65. 65 Newton per millimeter square. What is the actual shear stress as per the question? As per the question, actual shear stress is 50 megapascal itself. As per the question, actual shear stress is 50 megapascal. Okay, but here the shear stress we got is 65 megapascal. The shear stress we got is 65 megapascal. So that here our design is not going to be safe. So we have to design a safe diameter. Thereby Thereby, in this formula, substitute P in this P is equal to pi by 4 d1 square tau formula. Substitute the values, that is 100 into 10 to the power of 3 is equal to pi by 4. Keep d1 square as it is and substitute the shear stress value, that is 50 square. 50 square. Okay. Thereby d1 square is equal to 100 into 10 to the power of 3 into 4 by 50 into 50 into pi value. Now can anybody give me the pi d1 value? It will be around
50.
7 s
50.
50.
Yes, sir.
I think it will not be 50. Ah yes, okay. 50 Newton per millimeter square. If you see comparatively, 44 and 50 is having a difference of 44 and 50 is having a difference of only 6 millimeter. So you can go with the value whatever you have got over here. Whatever the value you have got over here, if not you have substituted over here, you can consider that is a safe design. Okay, if not, you can go for actual for finding actual diameter. That is, actual diameter of the knuckle should be 50 millimeter. Actual diameter of the knuckle should be 50 millimeter. According to your comfort, you can go. You can solve up to here, and you can continue for the third point. If you are not satisfying with this, you can find out given answer, and then you can go for the step number 3. That is according to your comfort. That is according to your comfort. Okay, you can follow either of those processes. Either of those processes. Okay, next step number 3. Step number 3. Okay, can anybody tell me what is step number 3?
Diameter.
Diameter of diameter of I. Diameter of I. If not, you can call it as thickness of I also, because both formulas are same. P is equal to d2 minus d1 into thickness into normal stress. Okay, both are same. So diameter and diameter of the eye, if not thickness of the eye, you will be writing same formulas with only one difference. That is, instead of sigma value here, I will write tau value. That is the only difference. Okay, anyway, let us find out what is shear stress over here. We know P value, we know D1 value, we know D2 value, we know T value. Okay, even sigma value has been provided in the question. This value also we know. But here, what we are going to do is, we are going to find out shear stress to verify our answer. We are going to find out shear stress to verify our answer. Yes, any doubts? Any doubts? Okay. Now, shear stress is equal to P by these all values. That is, P is nothing but 100 into 10 to the power of 3 by D2. D2 is 88 minus 44 into T value. T value is, can anybody give me what is T value? 55?
Yes, sir.
55,
55.
55 into 65. Okay, somebody will be writing that, sir, I think we have got d1 is equal to 50. Why shouldn't I substitute 50? Okay, you can go with your answer. You can
No,
substitute d1
65 will
is
not
equal.
come.
Yes,
65.
65 is wrong.
We should not take no, sir. We are finding stress on it.
Oh, yes. We are finding stress only. Correct. Correct. We are finding stress only. Okay, any of the values you can go. You can go with 44 or you can go with 50. Now you can give me the answer, that is sigma is equal to how much the value you got.
41.
Definitely it is less than the value that is being provided in the question. It is less than the value of 65 Newton per millimeter square. Hence your design is safe. Hence our design is safe. Hence our design is safe. Hence our design is safe. Okay, similarly, fourth formula and third formula both are same. That is, here I have written diameter, here I will write thickness of I. Okay, though the formula is having a small difference, that is, P is equal to d2 minus d1 T into tau. Instead of shear stress, here we will be finding, instead of a normal stress, here we will be finding shear stress. Thereby shear stress is equal to 100 into 10 to the power of 3 by p value. P value is, sorry, this is p value, d2 is 88 minus 44 into t value. T value is nothing but 55. Both are same. If you see, both are same. That is tau is equal to 41. Rendu same. You can see that both are same. But here it is normal stress. Here it is shear stress. Here it is normal stress. Here it is shear stress. Both values you will get same. Both are 41 Newton per millimeter square only, which is less than, this is 15 Newton per millimeter square. So our design is safe. Our design is hence our design is safe. Hence our design is safe. Here also our design is safe. Hence our design is safe. Hence our design is safe. Similarly, we will be
But
going for, yes,
if we change D1 into 50, then D2 thickness value should also be changed, or else 88
yes.
only.
See, d2 thickness value will be depending upon d value. Okay. If
Yes.
you change d1 value also, d2 value will not be changed because it is depending upon diameter of the shaft, not diameter of the knuckle.
Yes.
So you will be getting d2 is equal to 88 only. It will not be changed.
Okay, sir.
And now, then the fourth step of, we have completed four steps. Fifth step is we are going to find, either you can write thickness, if not you can write diameter of eye only. Okay, one is with respect to normal, one is with respect to shear, this is with respect to crushing. We are having three formulas: normal, shear and crushing. Okay, here we have to write the formula depending upon crushing. Crushing formula over here, it is P is equal to D1 T sigma C. D1 T sigma C. Okay, here we know D1 value, we know T value, we know P value, we even know sigma C value also. But we have to find out sigma C value only. Thereby, sigma C is equal to 100 into 10 to the power, sorry, 100 into 10 to the power of 3 by d1 value. Either you can consider according to your comfort, it may be 50 or 44, into t value. T value, I think we have already found out, that is 55. Just find out this answer. This answer will be
40.
definitely 40. 40, which is less than 120 Newton per millimeter square, and hence our design is safe. And hence our design is safe. Hence our design is safe. Okay, these three will be for eyes. Step 3, step 4, and step 5. Step 3, step 4, and step 5 will be represented for eye. Similarly, see here, similarly, we have designed our, see, knuckle joint will be consist of four parts. This is one, this is nothing but one part. This is a fork, this is eye, this is knuckle, and also shafts. And also shaft. This is shaft and this is shaft. We have designed shaft design is completed. We have designed even knuckle, this one also completed. We have designed eye, this one also completed. Only one left over is, that is nothing but fork. One is left over, that is nothing but fork. We have to design fork. Okay, that is why here we have to again repeat two steps. That is step 3 and step 4 will be repeated again. Step 3 and step 4 will be repeated again with a small change. That is, here I am going for step 6. Here, diameter of fork, diameter of fork in, if not, let it be diameter of fork. Okay, the formula is, for the diameter of the fork, the formula is P is equal to d2 minus d1, d2 minus d1 into 2t1 into sigma. Only one difference you are getting. There it is t, here it is 2t1. There it is in the formula number 3, it is T. Here it is 2T1. That is the only difference. That is the only difference. Okay, we know P value, we know D2 value, we know T1 value. Still we know sigma value, though we are finding sigma value because it is a verification. Sigma is equal to 100 into 10 to the power of 3 by 88 minus 44 into 2 into T1 is nothing but 33, I think, thereby T1. Can anybody give me the sigma value?
34.
34 Newton per millimeter square, which is less than 65 Newton per millimeter square. Hence, our design is safe. Hence, our design is safe. Design is safe. Okay, and step number 7. Step number 6 and step number 7 both are same, but here I have written diameter. Here I will be writing thickness. Thickness of fork. Formula is same, that is P is equal to D2 minus D1 2T1. Instead of shear stress, a normal stress over here, I will be writing shear stress. I will be writing shear stress. Thereby, tau is equal to same. Tau is equal to same. That is 100 into 10 to the power of 3. Whatever I have written over here, I will be writing over here. Because there is only one change. Here it is normal stress. Here it is shear stress. Thereby both are same. By 88 minus 44 into 2 into 33, where I will be getting tau is equal to 34 Newton per millimeter square, which is less than 50 Newton per millimeter square. Hence our design is safe. Hence our design is safe. Hence our design is safe. Okay, last step, that is step number 8. Okay, I will be writing beside step number 5 because both look similar. Both look similar. Okay, that is step number 8 is equal to that is either you can write diameter, if not thickness, diameter of fork. Okay, similarly, as in case of I, it will be normal. This is shear and this is crushing and crushing. Normal, shear and crushing. Similarly, with respect to I also I have provided those 3 points. That is, here it is normal, here it is shear, and also here it is crushing. Okay, similarly, I will provide over here also. Let the formula for this is P is equal to D into 2T1 into crushing stress. Here it is D1 into T, here D into 2T1. D into 2T1. Okay, which look like similar. Now, let us find out the value, that is sigma C is equal to 100 into 10 to the power of 3. D is equal to 44 and T1 is equal to, can anybody provide me the answer for T1? I think 33.
33.
Yes. Sigma C is equal to, how much is the value? It will be here around 30 or 40.
34.
34
4.
Newton per millimeter square, which is less than 120 Newton per millimeter square. Hence our design is safe. Hence our design is safe. If you see that this is very easiest problem, very easiest problem. The thing is that you have to draw the figure, and you have to substitute these values. You have to draw the figure and you have to substitute these values. Okay, drawing figure is very important. Without drawing figure, you will not get good marks. Without drawing figure, you will not get good marks. Okay, just note it down in your notebooks. Note it down in your notebooks. Note it down in your notebooks. Let me stop recording. If you are having any doubts, you can ask me now.